Hello, it's dumplet here. Here is another question based on the same figure. So this is part 2 of the same question. So we have the same figure. We have a square ABCD. We have two equilateral triangles ABE and BCF. Now we're asked to see if DEF are collinear. So we're asked to see if this result is actually true, because based on the given, it seems to be the case that DE and F lie on the same line. Now again, credits to the imat.ma Facebook page for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So let us try to get the results from the previous question. And in the previous question, we're asked to get what this angle was. So what angle BF was. And we got it to be 45 degrees in that case. So angle BEF was 45 degrees, and let us not forget the fact that, well, since we have equilateral triangles ABE and BCF, all the interior angles would be 60 degrees. So we have this to be 60 degrees. Now let's talk about what makes 3 points to be collinear. Aside from the fact that they form a line, well, it's kind of hard for us to see whether or not they will form a line unless we draw a very accurate figure. So we are going to use that we have angles given to make sure that these 3 points will be indeed collinear. Now, we can think of a line, so let's just imagine DEF to be like one straight line for now. If it was a line, then it must satisfy that, okay, we technically have this thing called a straight angle, so it must measure 180 degrees. So with that fact, I think we can say that, well, this angle must be 180 degrees. Now, if that's the case, well, I have two angles that make up the 180 degrees now. It's the 60 degrees and the 45 degrees. So I think to help us solve the question, we might want to try to see what this angle is. So let us put back all the observations we've done in the previous video. We found out that all these blue segments were actually of the same length because we have equilateral triangles and squares. Now last time we used the fact that BEF is an equilateral triangle, and we can use a very similar reasoning in triangle ADE. Well, because AD has the same length of AE, then it's going to be an isosceles triangle as well. So this red angle here, which is the angle we want, let's just call it X for now, must be the same as this angle here because triangle ADE is isosceles. So, well, we want to ask ourselves now, what is this angle? Because, well, these two red angles, so 2x plus this unknown angle, that should give us 180 degrees, and hopefully we can get X from there. So let us try to see what this angle is. Again, last time we used the fact that ABCD is a square, so this would be a right angle. And, well, this angle, it's part of an equilateral triangle, ABE, so this angle would be 60 degrees. Well, we can just find this unknown angle easily by just subtracting 90 and 60. So 90 degrees minus 60 degrees, that should give us this angle. So this angle would be equal to 30 degrees. Again, we can always verify by 30 plus 60, that's going to be equal to 90. But there we have it. This angle must be equal to 30 degrees. We can now make up the equation that we want. Well, this is 30 degrees, so I think these two x's, if I combine the two x's, that should equal to 150 degrees, because 180 minus this 30 degrees should equal these two, so that's 150 degrees. So 2x is equal to 150 degrees. We divide both sides by 2, so x would have to be equal to 75 degrees. Now, let's put 75 degrees back into the given. Now, since 75 degrees plus 60 degrees plus 45 degrees, you guys can check this on your own, it's going to be equal to 180 degrees, satisfying the straight angle condition. We can finally say that points D, E, and F are indeed collinear. Now, in fact, we can find a lot of linear pairs in this figure. That's also going to prove that DEF are collinear. Well, we can have a linear pair, DEA and AEF. Or on the other hand, we can have a linear pair, DEB, angle DEB, and angle BEF. But whatever method we use, we should be able to realize from the fact that we can have this 180 degrees as a sum of these three angles, and we can use the fact that, straight angles technically have an angle measurement of 180 degrees. And this will do it. We can now finally say that points D, E, and F are collinear. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye!